Hey everybody, in this video we are going to be going through most of the all the trig identities that you should know. We're going to try and not prove any of them. You can look up the proof somewhere else. This is just a way to try to memorize the least amount as possible to know the most amount of identities possible using the ones you memorize. So just a quick reminder that an identity is a math equation, I guess, or expression, or an equation that is always true no matter what variable is in it. So that's why there's often no variables inside when we do them, until we apply them to somewhere where we can put any variable inside, or any value for that variable. So we're going to go through most of them, but in a way that relates all of them to each other, or at least some of them to some you should know already, and trying to use some of the more simple ones to remember the hard ones instead of directly memorizing them. So you can come up, if you forget them, you can still come up with them on the spot. So we're going to start off with some of them that you should know already, and we'll build up from there. And so just a quick reminder of the three basic ones. We have sine, the opposite over the hypotenuse of a right angle triangle. The cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The reciprocals of all of these: cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So hopefully you already know you already know this one, but one trick you can follow with this one is that each pair only has one co in it. So notice how there's no co in sine, but there's a co in cosecant. Then how there is a co in cosine, but none in cosecant, and tangent doesn't have one, but cotangent has one. So that's, if you don't know this yet, then that's one way to remember it. And then you also know from grade 11, I believe, that sine over cosine equals tangent, and cosine over sine is cotangent. And we're not going to prove these, but I'm going to assume that you have already done so in the past. So you already, okay. Obviously, it's probably right in front of you. So we're going to move on to the next one you may or may not have covered in grade 11, which is the Pythagorean identity. So the Pythagorean identity is one you should memorize, or should already have memorized. Sine squared plus cos squared equals 1. It doesn't really matter. Well, obviously you should memorize that form, and that is the most helpful form, and and the other ones you can derive from this core form. So if you're set on memorizing only a select few, go ahead and memorize this one right here, because you can manipulate it any way you want to get to another identity that you can sub in somewhere else. So if you divide all of these by sine squared, you'll get 1 plus cos squared over sine squared. That is our quotient identity, so that will be cotangent squared theta is equal to 1 over sine squared, which is cosecant squared theta. So we can also divide all of our terms in our core Pythagorean identity by cos squared. So that gives us sine squared over cos squared, which is tan squared. Don't know why I did that. Cos squared over cos squared is 1, obviously, and then 1 over cos squared is secant squared. You can also subtract. You can also isolate for each of sine theta, or sine squared theta, and cos squared theta. I would not memorize this. Just do it if you need to. As it comes up, just sine squared is equal to 1 minus cos squared, and cos squared theta is equal to 1 minus sine squared. So we're going to use these a lot, and we're also going to use these two to help us find our double angle. Is it double? I think so. we're going to use that to also write other forms of our double angle identities. But first, we are going to look at our compound angle. So that's your a plus b, a minus b. So with our compound angle identities, we can memorize them. I find that it is a very similar way to how we memorize product rule and or quotient rule. It's a very similar process. So we're going to start off with sine and cos. So we have sine a plus or minus b. These can be any two angles that make up a bigger angle, or a smaller angle if it's a minus. And it can be alpha and beta. It can be happy face, smiley face, or happy face, sad face, or whatever. Just this one's the first one, and this one's the second one. So, sine a plus b, we have sine of our first angle, cosine of our second angle, same sign in between. So if we started with a plus, it will still be a plus. If we started with a minus, it will still end up being a minus. And then we'll have cos of our first and sine, or cos of our second, sorry. Cos of our second, sine of the second. For our cosine, we have cosine a plus or minus b. So this will give us the cosine of our first angle times the cosine of our second angle. And then we're going to have the opposite sign as here in between. So if we started with a plus, we'll have a minus. And if we started with a minus, the second sign will be a plus. All right? So, and then after that, we will have sine of the first times cosine, after that we have sine of the first, sine of the second. Sorry, I mixed them up because I usually do it the other order. So, from this, you can prove tan a plus b. Tan is equal to sine over cos, which is equal, so here it would be sine a plus b all over cos a plus b. You are free to go and figure out how to derive this by going through the long process. But for time's sake, we are just going to know that the compound angle for tan is tan of the first, same sign between, tan of the second, and then we will have, that will all be over 1, the opposite sign in between, and then tan of the first times tan of the second. All right, so, and if we had the opposite sign in the angle, we would have an opposite sign to every spot there's a sign in our identity. Okay. So I would definitely memorize, sorry, my phone's going off. I would definitely memorize the sine of the cos, and if you already memorized the tan one, good for you, but you can still go through the algebra to find and isolate for whatever this is using these two. So, all right, so we're going to move on to our double angles. Hopefully we can keep this video short enough. We are going to use our double angle identities, and instead of a plus b, we're going to use a plus a, because obviously a plus a is equal to 2a. All right, so knowing this and knowing our double angle identities, we're going to use those to find our double angle identities using our compound angle. So sine of 2a is equal to sine a plus a, which is equal to sine of the first, cosine of the second, same sign in between, cosine of the first, sine of the second. That gives us, obviously, we have sine x or sine A cos A and another sine A cos A. So we can collect like terms and write a coefficient of 2 in front of sine A cos A. So which that is our sine double angle identity. For cosine, we have we have cosine of A plus A. So we have the cos of the sorry, I thought my pen was still on the screen. So we have the cosine of the first, cosine of the second, opposite sign in between, and the sine of the first, sine of the second. So here we have cos A times cos A. So that is cos A squared, which is cos squared of A, minus sine squared of A, because sine A all squared is written as sine squared A. So remember that, don't mix them up, never expand a trig identity, never write it out. Okay, like that. So, oh yeah, you can write it out like that, just don't square it wrong. So, depending on which one you memorized, for the tan, you can still get to the tan double angle identity. So, assuming we have the tan double angle identity in our tool belt, we can go ahead and find our tan double angle identity. So, if you remember, we have tan of the first angle. Oh wait, shoot! I'm going to write it as tan A plus A. So for our tan A plus A identity, we have the tan of the first angle plus the tan of the second angle all over 1 minus tan of the first angle, tan of the second angle. This simplifies if you collect like terms in the top, 2 tan A over 1 minus tan squared A. So these are your double angle identities. So one more thing before we move on, we can also substitute our Pythagorean identity into the cos double angle identity. To get, obviously you can sub in for sine or sub in for cos to get your cos double angle identity all in terms of another. So let's take a quick look at that. All right, so if we know our cos double identity and our Pythagorean identity, in which we've isolated for each of sine and cos squared, or both of them are squared, sorry. So we can go ahead and sub in 1 minus cos squared for every time we see sine squared in our cos squared, or in our cos double angle identity. So that gives us cos squared, that stays the same, and we're going to sub in our 1 minus cos squared x. So obviously minus 1 stays the same, but we have a double sign. We have subtracting a negative cos squared x. So we have cos squared x plus cos squared x, which is 2 cos squared x minus 1. So this is another form of our cos double angle. The other form of our cos double angle, we have cos squared. We're going to start off with cos squared x minus sine squared x. We're going to sub in 1 minus sine squared every time we see a cos squared. So we have a 1 minus sine squared x minus sine squared x. So now we have 2 minus sine squared x's, so we have 1 minus 2 sine squared x. So what this shows, even though all these three are equal, you only need to know one of them to get, or you can obviously remember any three of them and then use Pythagorean to get the other ones, but I would emphasize memorizing that one as well as the sine double angle. tan is an interesting one because you can obviously use sine and cos, but it saves up a lot of time if you do memorize the tan. But obviously, you're probably short on time. So now we're going to look at a few forms of the half-angle identity. I would say this is new for a bunch of us, including me. So what we're going to do is we're going to start off with our double angle for cos, written in terms of cos, and then we are going to try to find the half-angle identity for cos from this. So we're going to start off with the cos half-angle identity. To start off, we're going to, I almost said start off like 3 times in a row. So we have our cos, that's a cos 2x, not a cos squared x, sorry. We have cos double x is equal to cos squared x minus 1. One thing we're going to notice here is that in the argument of our cosine function, sorry, that crossed out, you can still see it, that the double angle is obviously double this one, right? So that means this one is half of the double one. So we're going to try to isolate for cos x in this equation. It's an equation. So we are going to isolate for that. So we can add 1 to both sides. Sorry. We're going to add 1 to both sides. And then we're going to divide both sides by 2. So we're going to get rid of that. And then we're going to get rid of that. So I'm going to write it out again. So cos squared x is equal to cos double x, cos 2x, plus 1 all over 2. And the way it's written in textbooks, they usually have the 1 before the cos. But whatever. So obviously, okay, I wrote that wrong again. Yeah, oh no, that's correct. So, okay, so we know that the angle here is double the one here, or the other way around. This angle is half of this angle. So we're going to write this in a different way, but it will still mean the same thing. So what we're going to do is we're going to replace the x and the 2x with a 1/2 x and an x. So this will become x over 2. This will just be x, and they'll still be equal. Let's put that there to make it better. So that's still equal because the relationship is the same. So now we have cos squared of the half angle. We want cos of the half angle without the square. So to get rid of that, we're going to take the square root of both sides. And since we have an equation we're starting out with, we're going to have a plus or minus right in front of our square root. So that gives us a cos half angle is equal to the plus or minus square root of, oh yeah, the stuff inside, sorry. So this is our cos half angle identity, but we have to consider what sign we choose when we take the square root. All right, so we're going to have to take, all right, so where cosine is positive, some of you use some poem or something, but there is a, all right, so cosine is positive this way, so that is when you would use your positive square root, and this is where you use your negative square root. But make sure that it is when your half angle is a positive or greater than or less than pi by 2. So if it is your original angle, you would, if given your original angle, let's say was let's say original angle was pi. Your half angle is actually pi by 2. Or actually, pi is not a good one to use. We're going to just use degrees. So let's say your original angle was 150 degrees. You need to remember to, it's not checking where 150 is. 150 is over here, right? But we need to know where pi by 2, or the x by 2 is. So that would be 75. So you would be checking in quadrant 1 and not quadrant 2 for this, right? So hopefully that makes sense, because that's new for me. So now we're going to find our sine half angle identity. We're going to start off with a form of our Pythagorean in which we isolated for sine squared is equal to 1 minus cos squared. So we are going to substitute our cosine half angle. So we know that the cos squared of the half angle is equal to all this. So we can write this as sine squared of half of x is equal to 1 minus all of this. So that gives us 1 minus 1 plus cos x all over 2. We can write this all over a common denominator. Sorry. So we have a 2 minus 1 plus. So 2 minus 1 plus cos x. That might help. All over the common denominator of 2. So 2 minus 1 is 1. And then we're going to subtract cos x over 2. That's still equal to sine squared. So now, to get rid of the squared, we're going to square root. Sorry, I'm running out of room. So for our sine x over 2, we have plus or minus root 1 minus cos x over 2. So that is likely new to you. So as long as you know your double angle and you can find one of them, and if you know one of them, you can find the other. So now that we know both sine and cos, we are able to find our tan. So I'm gonna move everything around on the screen to make it more organized. All right, so knowing our sine half angle identity and our cos half angle identity, we can use our quotient identity to find our tan identity. So I'm actually going to go through and find it because I haven't actually done this before. So our tan half angle identity is going to be equal to the sine half angle identity over our cosine half angle identity. So it's equal to this divided by this. So it's going to be plus or minus 1 minus cos x over 2 all over 1 plus cos x over 2. So if both the numerator and the denominator of our fraction are under square root signs, we can write the entire fraction under a square root sign. And also, since I use an x, let's make that an x. So x is the same in all. It can be, even though x can be any angle, it's the same angle in each of these terms. So both of them would be actually, never mind. Whatever. I don't know what to do with the signs, but they're probably going to cancel anyway. Okay. This thing doesn't mention any signs, so we're going to skip over that. Obviously, the twos will cancel, so we are going to get 1 minus cos over 1 plus cos. So that is one way to write. This is one form of our tan half angle identity. So we are also going to find another form of this, because the tan half angle identity is one of the identities that has a lot of forms, and they're going to pop up in derivatives and whatever. So we're going to keep going. So obviously this one is an important form, but there are still other forms that we can find useful. So what we're going to do is we're going to do some algebra on this form. So we have 1 minus cos, 1 plus cos. So we're going to multiply both the top and the bottom by 1 plus cos. Well, this will create a 1 minus cos squared in the top. And that will help us as we keep going. So we are going to, this gives us big square root a 1 minus cos squared x on top and a 1 plus cos x squared on the bottom, all squared on the bottom. And from our Pythagorean identity, we know that 1 minus cos squared is equal to sine squared. So hopefully that makes sense. So now, actually, we didn't get rid of the plus or minus. So instead of having the plus or minus inside here, the plus or minus goes into the outside of the square root sign. So I'm sorry if you erased something. So now we have a fraction inside a square root, and both the top and the bottom of the fraction is all squared. So we can unsquare everything and then write less. So this gives us, this is going to give us a sine x, a plus or minus sine x over 1 plus cos. Sorry about that. So that is another form of our tan half angle identity. I'm not sure if there's another one. All right. So also, if we, instead of multiplying by 1 plus cos, if we did 1 minus cos, if we multiply both the top and the bottom by 1 minus cos here instead of 1 plus cos, it would get a similar result that is also equivalent, which would have been 1 minus cos x all over sine x. This would probably also be plus or minus. So that's it for most of the identities that relate to each other. Now, there's a bunch of them that are kind of standalone, but you can try to use some logic and some graphing knowledge to remember that. So in lecture, there is the concept of an even and an odd function that was probably covered, or not. So what this basically means is that cosine is symmetrical about the y-axis. So in our first positive rotation, we have something that looks like this. In our first negative rotation, we have something that looks like this. So obviously my drawing is not that great, but it is symmetrical. So let's say I have anywhere on x. So let's say I'm here, that's positive x, right? If I go to negative x, it's still the same y value, so still the same output. But with sine, it's not the case because it is not symmetrical about the, that's not vertical. It is not symmetrical about the y-axis. However, if you reflect it twice, if I reflect sine in the y-axis and the x-axis, I'm going to keep going this way. So let's say I go x units this way, this gets me here. If I go x units the other way, that gets me on the exact same point, but on like the other way. So notice that this one's y, it's moved, so this is x, negative x. It's moved y units down. This one is going to move y units up. So hopefully that kind of makes sense. You can also do this with the unit circle. Shoot. So if we go and rotate our terminal arm x degrees clockwise, we can also, like positive x, we can also rotate it negative x. So if our sine is so obviously this number is positive, this number is negative, and then it's positive that way. So if we take the sine of negative x, it's going to be equal to the sine of negative of the sine of positive x, because sine is in the y-axis. And also, no matter if both numbers are the same, but just different signs, obviously the cosine will be the same. I said I wouldn't prove anything, but this one's kind of confusing. If you don't look at it the right way, it'll be confusing. But this is important to remember, because there's multiple choice questions where they ask for things that may or may not be equivalent, and they're not going to all look the same. You're going to have to change the look of some of them without changing the value, using negative angle identities as well as supplementary angle identities. So we know that sine and cosine are periodic with a period of 2 pi. So this one's not really an identity. It is an identity, it's always true, but you obviously don't need to memorize it, right? So every 2 pi will be the same number, and then cos of x plus 2 pi is cos x. So all right, I wrote it the wrong order I wanted to show the first time, so I'm going to change that really quickly. All right, so these would help with I think the cube groups questions. I think, don't know where my mouse went. I think. Okay, so I don't know how the next ones relate to those. They're probably standalone, but also know that the sine of pi minus your angle, let's go x, pi minus x is sine x, and also cos of pi minus x is negative cos x. So these are pretty important, as well as the cos negative x and sine negative x. So obviously, graphically, so obviously pi isn't just pi, it's also your 180. So let's say I have a terminal arm rotated x degrees. Pi minus x would be from pi and rotated the other way, negative x degrees. So from, oh, sorry. Let's see if I can erase this. So that angle is x, and then this angle is pi minus x. So notice that sine is opposite over hypotenuse, and these are both positive and are the same number. So that's why sine is still the same. However, cosine is, you can think about it as x over the hypotenuse. Hypotenuse always has the same sign, but your x is obviously in the negative, right? This is positive, like in your x-axis. Sorry, I apologize for naming my angle x, but this is the positive x direction, and this is the negative x direction, and that's what determines what sign your cosine is. So that's why your cosine is negative. So along with your, so sine negative x is equal to negative sine x. This one's not as important. These are not as important as these four. Sorry, I should probably write the same thing I say. So these four come up the same. Have come up in the past and will probably come up again. So let's wrap this up. So at the end of the day, sorry, I would strongly recommend knowing these four. So obviously knowing what they all mean, that is very, very important and should have been introduced to you a very long time ago. So hopefully you know those already. So, and hopefully you know this one too, and you know your reciprocals, you know the Pythagorean, and then knowing your a plus or minus b and your cos plus or minus b, that will help a lot. But it's also the same. These are the same as memorizing your product and quotient rules. It's a very similar process. Once you do that and you can combine that with this, you basically can use these to find all the other ones. So if you don't have them all memorized already, you can basically, what you could do is once you get the paper, you can write down all the ones that you haven't memorized yet on it, or the ones you have memorized, and make your own formula sheet on the spot. So, and also, as you're stressing to remember all your identities, make sure that you don't neglect to remember all your trig derivatives, which, well, I won't talk about here. All right, hope this helps. I thought this would be a lot shorter, but the half angles were new to me and might as well be new to you, so I took some more time to derive those. But hopefully I've shown you a way that it's okay if you haven't memorized them all. Just make sure that you already know these, and if you are going to memorize like a select few, like know them by heart, learn these two. All right, and remember that sine is they switch the ratios, but the sign is the same, right? One last thing that I didn't point out with our sine and cos compound angles, which I'll point out right now. So I'm going to point out the key differences right now. Sorry. All right. So you'll notice with our, I probably should have done this in the middle of the video, but I'm doing it now. Sorry. So sine switches your ratios, but the sign stays the same as whichever one you started with. Okay. And then you notice that cos, it's two of the same ratio with each angle, but then the sign is switched. So this one's the same, sine is the same, cosine is opposite sign. Opposite sign, however, your ratios are the same ratio twice, but sine is the other ratio. So make sure that you remember these, make sure that you know the stuff you already know. Hopefully your knowledge bank is bigger than what's on the screen right now. But if it isn't and you're rushing to memorize them, just take these and manipulate them as you need to, okay? And also just don't be too loud, but read them out loud as you do them, okay? That's, if you want, like from the video, that's how I remembered them. Do whatever works for you. But I found that saying it out loud as I do it for this and for product quotient rule, whatever, just say the rule out loud whenever you're doing it. Okay. And I'm sorry this took 40 minutes. And thank you for watching the whole thing. If you did watch the whole thing, and I hope this helps you. Have a great day.